Hello people, now we have reached to the last part in the topic of electricity and chemistry, which is chemical cell. So now let's take a look what does it mean by chemical cell. What is chemical cell? A chemical cell consists of two metals and an electrolyte. The more reactive metal is the negative terminal. Electrons flow from it. What does the energy change we have in the chemical cell? Chemical cell converts chemical energy to electrical energy. Overall, a redox reaction occurs in the cell that causes the flow of electrons. The potential difference detected by the voltmeter indicates the presence of electrical current. This is how a chemical cell looks like. To build a chemical cell, you must connect two different metals. Okay, for the example on the slide, we use a strip of magnesium, a strip of copper, and a light bulb like this. Alright. After that, we stand the strip in the dilute solution of sodium chloride. The sodium chloride solution acts as an electrolyte. Now you will see something amazing, that the bulb lights up. This means a current is flowing. And you must remember, in the chemical cell, we does not use power supply like in electrolytic cell. And one more thing is, we must use two different types of metal as electrodes in the chemical cell. In the chemical cell, you must determine which one is anode and which one is cathode. As you can see here, based on the reactivity series of metal, the position of magnesium is higher than the position of copper. Therefore, magnesium will act as a negative terminal in the chemical cell, while copper will act as a positive terminal. As magnesium acts as a negative terminal, magnesium will have higher tendency to release electron, and the electron flows throughout the external circuit towards the copper. Okay, now the negative terminal is known as anode in the chemical cell, while the positive terminal is known as cathode in the chemical cell. So this is what happened at the negative terminal, which is anode. There's always oxidation reaction occur at the negative terminal or anode. Therefore, magnesium metal will release electron to become magnesium 2+ ion. While for the cathode, which is positive terminal, copper will receive electron. Okay, copper ion will receive electron to become copper metal. Okay, dalam chemical cell dia agak terbalik sikit. Okay, dalam chemical cell, for the negative terminal is known as anode. And you must remember, at anode there's always oxidation process occur, while for the positive terminal, or known as cathode, reduction will occur. Okay. Other facts about chemical cell. Other metals can also be used as electrodes as long as they differ in reactivity. Any solution can be used as long as it contains ions, which is electrolyte lah. Okay, you could connect a voltmeter into the circuit to measure the voltage in the reprise of bulbs. The bigger the difference in reactivity of the metals, the larger the voltage and the more brightly the bulb will light. This means the farther the distance between metals in the reactivity series, the larger the voltage you will get. And one more thing, other fact about chemical cell is, chemical cell does not use a power supply. Daniell cell. Daniell cell is an example of a chemical cell. Okay. Cell. A Daniell cell is an example of a voltage cell where zinc metal and copper metal are used as electrodes, which are then dipped into their respective ionic salt solution. This means zinc electrode is dipped into a zinc sulfate solution, while copper electrode is dipped into a copper 2 sulfate solution. Both salt solutions are connected by a salt bridge or separated by a porous port. What is the function of the salt bridge and porous port? Okay, the function of salt bridge and porous port is to allow the movement of ions. Okay, based on the reactivity series of metal, the position of zinc is higher than copper. Therefore, zinc is more reactive than copper. In the chemical cell, the more reactive metal will act as negative terminal. So zinc acts as a negative terminal, while copper acts as a positive terminal. Okay. In the chemical cell, negative terminal is known as anode, while positive terminal is known as cathode. Therefore, anode will always undergo oxidation reaction, while cathode will always undergo reduction reaction. So what happened to zinc electrode? Since zinc is more reactive, zinc has higher tendency to release electron, and the electron flow out through the external circuit and reach to the positive terminal. So the half equation for the zinc is zinc metal release electron to become zinc 2 plus ions. While for the cathode, copper 2 plus ion will receive electron to become copper metal. So half equation ni dia menunjukkan reaction yang berlaku lah kan. So zinc release electron and then electron received by the copper 2 plus ion. Okay. So the overall half equation so means that you must add two half equation. Dua-dua half equation you kena tambahkan secara matematik. So lastly you will get the overall equation zinc plus Cu2 plus, okay, produce zinc 2 plus and copper. So dua elektron ni kita dah cancel out. Let's take a look at the second example of a Daniell cell. Okay, so we have silver and iron as an electrode, and then silver is dipped into a silver nitrate solution, while iron electrode is dipped into iron 2 nitrate solution. Okay, so this is the chemical formula for the iron 2 nitrate, and this is the chemical formula for the silver nitrate. Right, based on the reactivity series of metal, the position of iron is higher than the position of silver in the reactivity series of metal. Therefore, okay, iron will act as a negative terminal or anode, while silver will act as a positive terminal or cathode. So at anode, it will always undergo oxidation reaction. Therefore, iron will release electron, and then electron flows out through the external circuit, and then dia pergi ke cathode. Okay, so that's the oxidation reaction lah. So the half equation at the anode is iron release electron to become iron 2 plus ion. Okay, and then electron flow and receive at the cathode will be received by the silver ion. So half equation, silver ion Ag plus receive electron to become silver metal. Right, so you kena tambahkan kedua-dua half equation to get overall ionic equation. So overall ionic equation is Fe plus 2Ag plus produce Fe2 plus and Ag. Okay, kenapa kat sini tiba-tiba ada 2 dengan 2 kat sini kan? Because we want to cancel out the electron. So electron untuk half equation dekat negative terminal ni ada 2. Jadi dia tak balance kan dengan electron, number of electron at the positive terminal. Therefore, yang ni semua kena darab dengan 2. So that's why kita dapat 2Ag plus 2 electron and 2Ag. And then bila the number of electron dah sama, barulah kita boleh cancel out. So that's why jadi 2 silver ion kat sini and then 2 silver metal. Application of chemical cell. Okay, application number 1 is the hydrogen fuel cell. And the hydrogen fuel cell, hydrogen and oxygen combine without burning. It is a redox reaction. The energy is given out as an electric current. Like the simple cell, the fuel cell has a negative pole that gives out electrons, okay, or negative terminal lah, and a positive pole that accept them, and an electrolyte. So negative pole release electron, positive pole receive the electrons, and then dia mesti ada electrolyte lah. So function dia macam chemical cell. Both poles are made of carbon. The negative pole is surrounded by hydrogen and the positive pole by oxygen in air. The electrolyte contains hydroxide ions. Okay, this is what happened in the hydrogen fuel cell. Okay, this is our negative terminal and this is our positive terminal. So at the negative terminal undergoes oxidation reaction where electron is flows out from the negative terminal and then receive and reach to the positive terminal. Okay, so dekat negative terminal tadi dia kata ada hydrogen gas, while at the positive terminal there's oxygen gas. Okay, the electrolyte used is hot potassium hydroxide solution. Okay, so at the negative pole, hydrogen lost electron to the hydroxide ion. It is oxidized, therefore it will release electron. So macam ni lah dia punya Harvey equation dia. Hydrogen gas receive hydroxide ion, it will produce water and it release electron. A current flows through the wire to the positive pole. So what happened at the positive pole? Okay, the electrons are accepted by oxygen molecules. So oxygen is reduced to hydroxide ion. Half equation is oxygen receive electron to become hydroxide ion. But the concentration of hydroxide ions in the electrolyte does not increase. Okay. Right, adding the two half equation give the full equation for the redox reaction. So you will get the overall equation is hydrogen gas plus oxygen gas. It will produce water. Okay. Right, advantages of hydrogen fuel. Only water is formed, so no pollutants. The reaction gives out plenty of energy. 1 kilogram of hydrogen gives about 2.5 times as much energy as 1 kilogram of natural gas. We will not run out of hydrogen. It can be made by the electrolysis of water with a little acid added. Solar power could provide cheap electricity for this. Scientists also hope to make it from waste plant material using bacteria. But there is a drawback. Okay, hydrogen is a very flammable. A spark or lit match will cause a mixture of hydrogen and air to explode, so it must be stored safely. Alright, next, battery. Okay, a torch battery. I'm sure you are very familiar with this kind of battery. Okay, they are dry and easy to carry around. Okay. How does the torch battery looks like? Okay, the metal case is the negative pole and it is usually zinc. Okay, the positive pole down in the middle here. Alright, electrolyte is often sodium or potassium hydroxide made into a paste that will not leak. Right. It is often manganese 4 oxide packed around a carbon root. The manganese 4 plus ions accept electron to become manganese 3 plus ion. So these batteries are called alkaline batteries. The battery dies when the reaction stops. Car battery. A car battery consists of plates of lead and lead 4 oxide standing a solution of sulfuric acid as an electrolyte as shown on the right. Okay, yang ni lah. Okay, this is our electrodes and then electrolyte kita adalah sulfuric acid. Okay. Okay, act as a negative terminal while lead for oxide act as a positive terminal. So electrons flows from lead to lead for oxide. Okay. The lead plate react with sulfuric acid, okay, giving lead to sulfate. Okay. The lead react dengan sulfuric acid, it will produce lead to sulfate, hydrogen ion and electrons. So the lead to sulfate coats the plate. Electrons go off through the wire as electric current. It gets the car start, the motor working. And then the electron flows back through the wire to the lead for oxide plate. This also react with the acid to form lead to sulfate which coats the plate. So this is the reaction. Mungkin you tak perlu hafal apa reaction ni, cuma you perlu tahu macam mana dia function. Okay? Because the principle of battery, car battery, okay, adalah daripada principle of chemical cell. Comparison between electrolytic cell and chemical cell. Okay, sebab student always get confused between electrolytic cell and chemical cell. So kita tengoklah dia punya perbezaan dan dia punya similarities and different. Okay, on the left is the electrolytic cell and on the right is the chemical cell. So now we are going to look into the similarities between electrolytic cell and chemical cell. The first similarity is electrodes are deep into the electrolyte, must deep into the electrolyte. Second, oxidation reactions will always occur at anodes, while reduction reaction will always occur at cathode. So for the electrolytic cell, to determine anode and cathode, you must refer to the terminal of the battery. So kalau battery ni, this one is positive, so means that terminal battery, the positive terminal of the battery is connected to the anode, and negative terminal of the battery is connected to the cathode. While for the chemical cell, to determine sama ada dia adalah negative terminal atau positive terminal, you must be based on the reactivity series of metal. The more reactive the metal, it will have higher tendency to become a negative terminal or known as anode lah, and a positive terminal known as a cathode. Okay, and the electrons always flow from anode to cathode. Alright. Differences yang pertama, electrolytic cell converts electrical energy to a chemical energy, so that's why we need power supply in the electrolytic cell. Kalau dalam chemical cell, chemical energy converts into electrical energy, so there's no power supply in the chemical cell. Itu obvious sekali Okay, voltmeter here to read the voltage, atau untuk gantikan voltmeter kita boleh gunakan bulbs. Okay. Pairs of metal are the same type untuk electrolytic cell. So, contoh kita gunakan kedua-duanya adalah carbon electrode atau kedua-duanya adalah menggunakan metal yang sama. But for the chemical cell, electrode must be pair of different type of metal yang ada different reactivity. Okay. Alright. Okay, saya dah contoh. Anode in the electrolytic cell is connected to the positive terminal of the battery and cathode is connected to the battery's negative terminal. While for the chemical cell, negative terminal is anode and positive terminal is cathode. Untuk menentukan the negative ataupun positive terminal in the chemical cell, we must be based on the reactivity series of metal again. Alright. Let's take a look at the example of question about chemical cell. Okay. A student used the following electrochemical cell. The reading on the voltmeter was 1.10 volt. Okay. Question number 1. Draw an arrow on the diagram to show the direction of electron flow. Okay. Untuk tahu direction of electron flow, first you must know which one is a positive terminal and which one is a negative terminal. Since this is a chemical cell, so they are using two different metal as electrode. Okay. To determine which one is a negative terminal and which one is a positive terminal, you must be based on the reactivity series of metal. Okay, based on the reactivity series of metal, zinc electrode, position of zinc is higher than the position of copper. So zinc is a more reactive metal than copper. Therefore, zinc will act as a negative terminal or anode, and then copper will act as a positive terminal or cathode. So, electron will flow from the negative terminal to the positive terminal. Jadi, you kena lukis draw an arrow. So, lukis. Okay. Alright, arrow ni lukis. Okay, kalau dalam exam you kena lukis kat atas wire ni. So, lukis kat sini sepatutnya. Okay. Saya sebab susah nak edit, so saya buat macam tu lah. Okay, kalau awak lukis terus dekat atas wire macam ni. Alright. Question number 2. Suggest the change, if any, and the voltmeter reading if the zinc electrode was replaced with the iron electrode. Explain your answer. Now, zinc is replaced by iron. Okay. So, apa agaknya bacaan voltmeter yang kita akan dapat? So, kalau based on the reactivity series of metal, bila zinc digantikan dengan iron, the distance between iron and copper dah semakin pendek lah. So, bila distance pendek, dia punya voltmeter reading will be reduced. So, kita tengok jawapan dia apa Okay. Okay. The voltmeter reading would decrease. Okay. Reason dia kenapa? Because iron is less reactive than zinc. Okay. Next. Okay. Zinc electrodes have been used in cells for many years. One of the first was the cell in 1831. Okay. Ini dia gunakan for spot Okay, and the electrode used is copper and zinc. Sama macam soalan tadi. The copper electrode is deep into copper to sulfate solution, while zinc electrode is deep into zinc sulfate, and both solutions are separated using for spot. Right. Give an example for the following in terms of atoms and ions observation at zinc electrode. Okay. Electrode becomes smaller. Explanation dia kenapa? Because zinc metal, okay. Ini kita, of course lah, you kena tahu dulu yang mana adalah positif, yang mana adalah negative terminal based on the reactivity series of metal. So, zinc act as a negative terminal and copper as a positive terminal. So, zinc will undergo oxidation by losing electron. So, zinc lose electron to form zinc ions. Okay, kat sini. At the copper electrode, copper 2 plus ions receive electron and become copper metal. Okay. When the current flow, charged particle move around the circuit. What type of particle move through the electrolytes? Okay, you must remember that dalam electrolyte, dalam solution, particle yang bergerak mestilah ions. Okay. And then, which particle move through the wires and the voltmeter? It is electrons. Okay, ingat yang ni pun selalu salah. Dia tanya elektron move dekat mana. Electrons tak move dalam solution, tapi elektron dia move throughout the external circuit. Dalam solution hanyalah ion sahaja. Okay, get back to the porous spot. Kat sini tulis stop flow solution from mixing. Tapi the main function of the porous spot selain dia separate the two solution is to allow the movement of ions. Remember allow the movement of ions. In the same time dia stop solution from mixing. Soalan yang terakhir. Okay, we have 3 set of chemical cell. Okay, using different pair of metals. Okay, but the same electrolyte, which is dilute acid. Okay, chemical cell yang pertama dia gunakan zinc dan copper. Chemical cell yang kedua dia guna zinc and tin. Chemical cell yang ketiga dia gunakan copper and tin. Chemical cell yang ketiga dia guna zinc and tin. Okay, based on the reactivity series of metal, dia dah bagi tahu kat awak lah kat sini. Okay, zinc is more reactive than copper, so zinc will act as a negative terminal, copper positive. Okay, tin is more reactive than copper, so tin will act as a negative terminal. Zinc and tin. Okay, nanti kita tengok Right, question number 1. Why is the more reactive metal the negative electrode? Jawapan dia because more negative metal has higher tendency to lose electrons and form positive ions. Okay, 2 markah. Second, electrons flow from this electrode and enter the circuit. So elektron keluar lah daripada reactive electrode ni, and then keluar ke external circuit. Okay, how can you deduce that zinc is more reactive than tin? Kat sini. Macam mana? Because a bigger voltage of zinc copper as compared to the tin copper. So kita boleh conclude that zinc is more reactive than tin lah, sebab voltage dia lebih besar di sini. Question number 3, how could you change the zinc copper cell to have a voltage greater than 1.1 kat sini? So zinc copper kita nak dapatkan voltage yang lebih tinggi, so kita mesti tukarkan zinc dengan more reactive metal kat sini, sama ada kita gunakan magnesium ataupun aluminium. So kita bagi tahulah how could you change, kena bagi contoh. Okay, change zinc with aluminium or magnesium. Okay, or calcium. Kenapa tak boleh guna potassium dengan sodium? Tak boleh sebab potassium and sodium is two reactive metal. Okay, impossible dia berada dalam keadaan macam ni lah, sebab dia sangat sensitive towards moist pun. Okay, so dia tak boleh berada udara, apatah lagi nak berada dalam solution yang macam ni, acid ni kan. So dia tak sesuai. Right, complete the labeling of zinc tin cell. Okay, based on the reactivity series of metal, the position of tin. Ada ke kat sini? Oh, tak ada. Okay, sepatutnya tin kedudukannya adalah dekat mana Okay, dia mesti berada di bawah iron. So, zinc will act as a negative terminal and tin will act as a positive terminal. Macam tu je lah. And then, dia punya bacaan voltmeter adalah 0.6. Yang ni kena kira sebenarnya. Okay. So, saya tak boleh nak tunjuk kat sini. Tak apa. Next time Alright, that's all. Thank you.